Flip video about Lewis structures with double and triple bonds. Okay, so we learned how to do Lewis structures with single bonds, and so doing them with double and triple are pretty much the same, but we have to be careful and check our answer in the end. So let's take a look at our first example, and this is CO2, carbon dioxide. So I noticed that it's a molecular compound, nonmetal and nonmetal, so there's going to be sharing of electrons. There's one atom of carbon times 4 valence electrons. I looked on my periodic table. And there's 2 atoms of oxygen times 6 valence electrons, again because oxygen is in the 6th column for 6 valence electrons for 12. My total valence electrons are 16 valence electrons. So once again, you have to still total up your valence electrons. Now the same rule applies. I usually take my first atom and I put it in the center. Then the second rule said bond the oxygens, or bond the other atoms to the center. Remember, we use electrons to bond. So I have an oxygen here and an oxygen here. So far I have 4 electrons used out of the 16. Well, nobody is an exception, so everybody wants 8 valence electrons, and I have to use up to 16. No more, no less, exactly 16. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Now carbon has 8, okay? Now I want to go ahead and make the oxygens happy. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. Oh no, something went wrong here. While this one is happy with 8 electrons and this carbon's happy with its 8 electrons, this one is not happy. It does not have 8 electrons. And I ran out of electrons. Remember, 16 was my max. So what happens? Well, in order to realize that you need a double or a triple bond, you have to go through a structure and figure it out, right? As soon as it doesn't work out, I need to say to myself, I need a double or a triple bond. So I start off by taking here's my carbon, 1 bond at a time, and I try to double it. So instead of there being 2 electrons, I double it to 4. That's what a double bond is. And I put the oxygen on this side. Now I have a double bond. So this oxygen has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. Okay, then I'm going to make this one happy. So I've got 4 here, 5, 6, 7, 8. 8 valence electrons, happy. Now I'm going to try to make this side happy. I need to bond it to oxygen. I'm going to first start with a single bond. I already put my double bond here. Doesn't mean I need one here, but maybe I do. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, this carbon has 1, 2, 3, 4, 5, 6. See? 7, 8. Okay? So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Remember, I only can use 16. Uh-oh. This oxygen is still not happy. It has 1, 2, 3, 4, 5, 6. That's not good. I ran out of electrons. So this side must also have a double bond. So I'm going to put carbon in the center, double bond on this side, double bond on this side. Put my oxygen, put my oxygen. Now, this carbon has 1, 2, 3, 4, 5, 6, 7, 8. It doesn't need any more. Now I can make all these happy. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Check. You have to check. Now, if you remember, we can redraw this using our stick structure. So that's oxygen, double bonded to carbon, double bonded to oxygen. And I would like you to actually write your valence, or your other non-bonding electrons on the rest of your compound. Okay? All right, let's try another one. How about nitrogen bonded to nitrogen? So I have 2 nitrogens. Each one comes with 5 valence electrons that I found on the periodic table for a total of 10, valence electrons. That's how much I have to use. So I got nitrogen bonded to nitrogen, okay? And I first try to do a double bond, or sorry, a single bond, right? Always start with your single bond. Nitrogen bonded to nitrogen. Single bond. Let me try that first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one's happy, but clearly this one's not. So a single bond is not good. Now I'm going to try a double bond. Nitrogen, double bonded to nitrogen. 1, 2, 3, 4. So this one has 4. 5, 6, 7, 8. 1, 2, 3, 4. 5, 6, 7, 8. 9, 10. This nitrogen's not happy. It has 1, 2, 3, 4, 5, 6. So I need a triple bond. So let's try a triple bond. 1, 2, 3, 4, 5, 6. Okay, now this one has 6, 7, 8, 9, 10. So now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one has 8, this one has 8. And I checked against my 10. So if I want to draw that, I go 1, 2, 3. Put the sticks in for the bonds. Each stick is 2 electrons. 1, 2, 3. And I put my extra electrons. And I could have put them here, here, or here. Same thing on this side. Triple bond. Okay, so if you remember, we said a single bond has 2 electrons, a double bond has 4 electrons, and a triple bond has 6 electrons. Each bond represents 2 electrons. All right, the last thing is something called resonating structures. So let's take a look at this right here. Okay, I have 18 valence electrons. And when I actually make this compound, okay, sulfur ends up being bonded doubly on one side to oxygen and single bondedly to the other oxygen. Try and see if you could figure that out without using my help on that. Okay, so when all is said and done, then 2, 4, 6, 8, 2, 4, 6, 8. So I got 2, 4, 6, 8, 10, 12, 14. So I also need to make sulfur happy. 15, 16. So 2, 4, 6, 8, 2, 4, 6, 8. Look how I made sure everybody had 8. Everybody had 8. Everybody had 8. You should check that. And then I went back and checked to make sure it fulfilled 18. A resonating structure is one where we could have put this double bond here and the single bond here. So it could have looked like this, like I just had it, or I could have had this on the other side. In other words, this double bond could have moved to the other side. This is called a resonating structure, when you can have more than one Lewis structure. The bond resonates, it goes back and forth. It could have been here or on this one. Both of them are correct. In this instance, there's 2 places that double bond could have gone. That's called a resonating structure. That's the end of the video.